Today I will talk about the few remarks on the axiom physics. There are two possible frontiers in the particle physics. First of all, the one is the energy frontier using the high energy scale, like as a TB, for example, the LIGC induction. We can prove the high energy scale particle like as a supersymmetry. There's also the other frontier, intensity frontier, which is the luminosity R is a large. So the events of the number of the events is larger in this case. In this case, the energy scale is small, and also the coupling is small compared with the standard model. And also there are other frontier, cosmic frontier, which is time is large. And the action is included in the intensity and the kissing frontier because it has a ultralight mask. In the dark matter theory, there are several portals which connect the visible structure and dark structure, possible Higgs portal and the axion portal as a source color, and the neutrino portal and the vector portal as a spin one vector field. The coupling between the axion field and the other standard model fields, the proportional coupling is proportional to the one of the F, where the F is axion decay constant. For example, the coupling between the axion fields and the vector fields couplings are given like that, and the coupling between the axion and the fermion fields the following with the co-interaction term. So I'll now talk about some view, some several remarks and action. First, in the cosmological point of view, action can be the candidates of dark matter. Actions the couples like that. Build pi and the build strength. And if we expand this, the build strength up, and the inner products of the electric and magnetic fields turns out. Because of the small couplings, the actions get to the two photons. This mode is extremely small, so the axion just can be the stable dark matter. The axion productions can be realized by using the misalignment mechanism typically. That's a Hubble fraction term for the just color field in expanding universe, and it gets a specific large amplitude, and over the cosmic theory, it behaves like the oscillation. Also, there is other possible production mechanism like the double productions, but such other ways should be considered the hard one and the cold dark matter. And the action such are conducted over the from the space of the action mass and action coupling. And the actions are inserted as a current term in the maximum equation. So we should consider the modified action electrodynamics. For example, in the Paradise law, in the right-hand side, last term contains the gradient through the axion field as a current term. Also, axion can participate in impulsion, which is called the natural impulsion or hybrid impulsion with the additional field. For impulsion, flatness of substantial shift is guaranteed, and such a cosine form of the axion field can provide it. And if we consider the QCD axiom to argue that the strong CP problem by using the U1 Paskins symmetry solutions. And Lagrangian contains a coupling between the axiom and the SS3 blue build strength GG2 dot. And in this case, the axiom mass is fixed with the axion decay constant up. The typical scale of the axion mass is 10 to the minus 6 electron volt, and axion decay scale 10 to the 12 ZB. This relation coming from the axion mass times axion decay constant has a similar scale with the higher mass than the pion decay constant. And in the remaining time, I will talk about the two things, axion quality problem and the relaxion. The axion quality problem is the following. This type, the quantum gravity effect like the Pascal symmetry, but the Pascal symmetry should be maintained to solve the strong CP problem, so the quantum gravity effect becomes should be the small. And the second topic is the relaxion. The relaxion is adopted to explain the Gaze-Araki problem on the Higgs mass. There's coupling between the relaxion field pi and the Higgs field. So the Higgs mass has a dependence on the relaxion field. The relaxion field lives on the relaxion potential, and over the cosmic history, after the relaxion potential value becomes a negative, it has the behavior of the wiggle. So it provides the relaxion Higgs mixing phenomenology. Additionally, the axion can also help the baryon symmetry of the universe. Another model includes the B plus L anomalies, CP violation in the baryon circuit, electroweak phase transitions as a crossover, but is not sufficient. If the axion participates in baryogenesis, there's one model of spontaneous baryogenesis. Axion evolved over the cosmic history, and it provides the constant, and it can give the chemical potential view, and the baryon symmetry can generate this, which is occurs faster than the demonization. Now, also I want to talk about the several model for the axion. There's also the ultralight axion, which has a typical mass as 10 to the minus 22 electron volt, and this can be constrained by the CMB, large-scale structure, Lyman alpha boys, the ship palladians of the blackers, and so on. There are several axion model, which includes coupling between the axion and the standard model particle. The minimal model is the PQWW, but in this case, the axion decay constant type A is a similar scale with the electroweak vacuum. So this is excluded. But other models, the axion decay constant Fa is extremely larger than the electroweak vacuum. For the KSVZ model, they include the additional Bion-Side model parameters, so the A psi of psi can provide the axion and the proton coupling in the loop level. And the DFSZ model includes additional Higgs sublab. So there's a coupling between the two Higgs and axion field, and this also can provide the axion tadon model particle coupling by using the axion Higgs mixing. And in this DFSZ and the KSVZ models, they provide the relation between the axion mass and the coupling. Here's some detailed induction search. In the Galaxy Hello approach, we can say that the helioscope group and for the helioscope approach, there's a selection. And in the laboratory approach, light shining the overall experiment as the photons convert to action and it becomes a photon. So for this arrow, the number of the photons per day is small, so it's hard to detect. And over the time space of the action coupling and action mass, for the small mass, there are the cosmological constants for the ultralight mass scale. And large mass has also physical constraints, and in the large coupling, there's a stabilization in the world, and here's helioscope at the solar system scale, and here is a galaxy halo, and this halo scope comes when touch the relations from the KSVZ and DFSZ model. And here is some for the the explanation for the helioscope. In the high-end magnetic fields, action fields convert to the photon fields, and by using the cryogenesis with the low temperatures to uh, reduce the noise. And there are some specific frequencies which correspond to the action mass, and there will be the resonance in the cavity and in the IBS have experiment and followed ADMX and touch the relations of the boundary parts. And the CP violation sources can come from the dimension 6 plate. There are several types of the CP violation source of high dimensional plate, like the electron gluon CDMs. And it can be checked by the time reversal. For example, the electron fields are unchanged, but the spins are changes. So that we can classify the which term as CP violation source. And the electron dipole moment EDMs is the CP violation source. And the various sources of the BSM, like the supersymmetry and the Twix double model and axiom field can be source of the CP violation. And now we talk about some details of the axion quality problem. There are some several parameters around the quantum gravity effect, like as gravitational mass, amplitude derivative, and the Planck mass scale. And the such a gravity effects and the Pascal symmetry is incompatible. So the body gravity is the PQ symmetry is broken. So the axion quality problem is the high quality of the global symmetry, U1 PQ symmetry is required. This problem is depending on the UV physics. Here is axion and due to the coupling term. And one dimensional scale is smaller than the QCD scale. The mass of the actions are determined by the action decay constant like that. And also the cosmologically abundance is determined by the FA with the additional exponent. And by the quantum gravity effects, there is additional term in the potential. And to make the setup term it is still small to address the strong CP problem. The setup term with the dynamical field action should be still small, but the quantum gravity does not allow the global symmetry, so it's called accidental symmetry. And from the quantum gravity effects, there are additional potential term like that. High fifth power over the m Planck mass. And the coefficient for this C5 shift extremely small, 10 to the minus 52. This is the extreme fine tuning. So the high quality is required. And there are some resolutions of the such action quality problem. We can make the Pascal symmetry as a gauge symmetry to preserve sort of the such Viking.